Hi, obviously I'm not here, which is why you're watching this video with our video lesson today. You have a couple things to do today. One is watch this video, take notes in your notebook, make sure you're listening to me, listen with your ears, not just read. So you need to borrow headphones if you don't have them. The second thing you're going to do is you are going to do a worksheet. You only need to do one side of this. That's because the other side was for an activity that is too complicated to do with a sub. So you just need to do one side. All right, let's go ahead and get started with our lesson. I'm going to turn off the camera just so that you guys can see the screen better. And let's head on over to our PowerPoint. So our PowerPoint today is all over one-step equations and inequalities. Go ahead, pause the video, and title your notes that, and then unpause and come back. All right, our objective for this video is I will be able to solve one-step equations and inequalities and graph my solutions. So we're going to be doing a couple things with each one. Some of you guys might feel more comfortable with one-step equations and inequalities, and some of you guys might need a little practice. But the next day, we are going to start working on two-step equations. So you really need to have a solid foundation. All right, so how do equations and inequalities differ than expressions that we talked about? An expression yesterday we talked about does not have an equal sign. And so an equation or an inequality actually does have an equation or inequality has an equal sign or an inequality sign. So that's the big difference between an equation and an expression. And when you see one of these signs, it means that we have to solve them or simplify them a little bit differently than the expressions. All right, so let's go to the next slide. Go ahead and start your notes. The main goal for solving an equation or an equality is to isolate the variable. What we want is we want the variable, whether it be x or y or a, we want it on one side of the inequality or equal sign, and we don't want any numbers there. So we're going to end up with a solution or a number over here. And so we want to make sure that our variable is all by its lonesome on one side of the inequality / equal sign. So that's what we're looking for at the very end. Okay. So the golden rule for solving equations and inequalities is whatever you do to one side of the equation, you have to do to the other. And the reason that we do this is we have to keep the equations and inequalities balanced. So one of the strategies that your teachers may have talked about was when you have an equal sign or an inequality sign, you draw a line down the equal sign. And that kind of helps us balance of what we need to do, what we need to move across. So there are different symbols that you're going to be seeing in equations and inequalities. Please make sure to write these down in your notebook. After I go through all of them, if you need to pause the video, please do so. So our first type is an equal sign. Okay? And the way we graph it is just with a solid dot, a solid circle. It means it's filled in. Then we have our greater than. So x is greater than something. And we graph that with an open circle going to the right. Okay? I'm just going to put all of these in so you guys can see them at once. All right, so notice here how I have put all of the x's on one side of the inequality. You're not always going to have that, but if you make sure to flip it, then you should know that all of these are graphed the way that's on this slide. So it'd be a great idea to pause the video and write these down. Don't take too long, but definitely write these down. Notice how the signs that have a line on them or an equal are all filled in, so have what we call closed circles. Okay, and that's because, less than or equal to or equal to, or equal. So if there's the word equal in your sign, that means it's going to be a closed circle. If it doesn't have the word equal, or it doesn't have that line, let me try a different color. Notice how it will be a circle that isn't filled in, and that's what we call open circle. Okay, so keep those in mind. Okay, so let's go ahead and do some examples. Right? Go ahead and write this example down. You need to write x plus 7 equals 4. And let's go ahead and solve this. First thing I'm going to do is I'm going to draw my line down the equal sign. And then I need to get x by itself, so I want to move everything besides x to the other side. So I need to move this positive 7 because I want x by itself. So the opposite operation of adding is subtracting. Okay, so I'm going to subtract 7 from both sides. Some of you guys have heard that as additive inverse. What do we add to positive 7 to get to 0? Well, we add negative 7, right? So those cancel out. I'm left with x equals, and then we have 4 minus 7, which we need to add the opposite, right? So 4 plus negative 7 are two different signs, so we subtract. 7 minus 4 is 3. Since 7 is the larger one, our answer is going to be negative 3. Okay, so that's my solution. The next thing I want you to do, and this is what you're going to have to do on your worksheet, is you're going to graph it. And so what I'm going to do is I'm just going to put a line with arrows on both sides and just put a dash, and I'm going to put negative 3 there. Okay, now I'm just going to put a closed circle in there. It's the only answer I could get for my solution. Negative 3 is the only correct answer. All right, let's try another one. 15 is less than x minus 20. Okay, here we have to be careful. Notice how the x is on the right. When we graph it, it's easier if the x is on the left. So in order to do that, we need to flip the problem around so that x is always on the left. But in order to flip it around, we're going to put x minus 20 on one side, and we have to flip the inequality sign. So instead of less than, it's going to turn into greater than 15. Okay, and now I have, oops, didn't mean to do that. Oops, I guess I'll write it out again. So 15 is x minus 20 is greater than 15. Okay, so the open part of my inequality is still facing that x. All right. Let's go ahead and solve it. So let me draw a line down the inequality. And now I need to get x by itself. So the opposite of negative 20 is positive 20. Okay, so negative 20 plus positive 20 is 0. So I'm left with x. And bring down that inequality is greater than 15 plus 20 gives me 35. All right, now let me go ahead and graph it. So I'm going to draw my line. I'm going to draw a dash, and I'm going to put the number 35 there. And then since my inequality doesn't have that line underneath it, that means I'm going to put an open circle. And then x is pointing to the 35, so it's going to go to the right. So if we check it, if I say, hey, is 36 greater than 35? That's a true statement. Therefore, my line should go through 36, which it does. Okay? All right, let's try another one. On this one, we have negative 22 is greater than or equal to 11x. So same deal. We want to flip it around so it's easier to graph. So my problem is going to be 11x, and I need to flip the inequality, is less than or equal to negative 22. All right, this one's a little bit different because the x is attached to the x 11, if you guys remember from yesterday or Monday, that's called a coefficient. So remember, it's being multiplied together. So the opposite of multiplying is dividing. So we're going to divide both sides by 11. And some of you guys have used the multiplicative inverse. That's fine as well. All right, so 11 divided by 11 is 1, which gives me x, same as x, is less than or equal to. And then negative 22 divided by 11 gives me negative 2. And now I have to graph it. So I'm going to draw my line. I'm going to put my negative 2 here. And then since it has that equal sign there, so less than or equal to, I'm going to do a closed circle. And then it's pointing to the left, so my arrow goes to the left. Let's check to see if all of those work. So a number that's less than negative 2 is negative 3. So negative 3 is less than or equal to negative 2. Is that a true statement? True, which means that my line should go through negative 3, which it does. All right, let's try one more. This is an equal sign, so I need to draw a line down the equal sign. I have x over 14 equals 2. So over, or fraction bar, means division. So the opposite of division, the inverse, is multiplying. So I'm going to multiply both sides by 14. Okay. I'm going to do parentheses. So 14 times x over 14 cancel out. They give me 1x, which is the same thing as x. And then 2 times 14 is going to give me 28. So x is equal to 28. Let's go ahead and graph it. We have 28, and since it's an equal sign, it's just going to be a solid dot on 28. All right, why don't you guys try a few? I'm going to go to the next slide. We have 3 that you want to solve. Try on your own. So pause the video, give it a try, and then check back. All right, let's check back and look at your answers. So on the first one, you should have gotten x is less than negative 2, and you should have graphed it like you see. For the second one, you should have gotten x is less than or equal to negative 20, and graphed it like I've shown. And then for the last one, you should have gotten 56 equals x, or x equals 56, and graphed it like I've shown. If you have questions, please email me. I don't promise that I'll see it, but I will check in with you the next day. All right, so now it's practice time. You only need to complete one side of the worksheet. Make sure you turn in the worksheet to your guest teacher at the end of the class period.